Welcome back. In the last chapter, we talked about probability experiments. So these were things like flipping a coin, rolling a dice, picking random people. So these are probability experiments because when you do these things, you don't know exactly what's going to happen. You can only talk about the probability of something happening. A random variable is the numerical outcome of a probability experiment. And what do I mean by this? When you flip a coin, roll a dice, or pick a person, you don't get a number, right? You get heads or tails. You get I guess rolling a dice, you get a number. Picking a random person, you don't get a number. What I want to do here is I want to force numbers to happen. And the reason why I want numbers is so that I could talk about things like the mean and the standard deviation. So let me give you two examples here. Flipping 5 coins. Now, flipping 5 coins in and of itself, you don't get a number. Right? You get things like heads, heads, tails, tails, tails. Not a number. But I can force it to be a number by counting or measuring something. So in this case, I'm going to count the number of heads. Now I do get a number. Let me give you another example. Picking 5 random people. So here, you also don't get a number, right? If you pick 5 random people, you get 5 people. And now I'm going to force it to be a number by measuring their height and then taking an average. Now it is a number. So back when we talked about types of data and we talked about quantitative data, which were the numbers, we used the words continuous and discrete. Okay. Height here, right? When we talk about height, it makes sense to have any decimal as a height. So it makes sense for someone to be 5.531 feet tall. So this height example is an example of a continuous random variable. When we talk about number of heads, it doesn't make sense to talk about decimals here, right? So when I talk about number of heads, you should only get whole numbers. And in fact, because we're talking about 5 coins here, you should only get 0, 1, 2, 3, 4, or 5 heads. So flipping coins and then counting the number of heads, that's an example of a discrete random variable. So in chapter 6 here, we're going to focus on discrete random variables, and then in chapter 7, we'll focus on the continuous random variables. Probability distribution. Okay, this is just going to be a table. Sometimes it could be a graph, but for us it's going to be a table that lists all the possible values of x along with their probabilities. Okay, so in example 1 here, I have 3 tables. Some of these are probability distributions and some of these are not probability distributions. Which one is and which one is not. So I'm going to look at the second table because something jumps out to me. So the thing that jumps out to me here is this negative 0.01. So the x's here are listing out all the possible values of x. Okay, so 3, 6, 9, 12, 15, 18. Okay. The p of x column here is supposed to be listing out the probabilities. What's wrong with negative 0.01? Probabilities should be numbers between 0 and 1. Okay, so this middle table here is no good because that's not a probability. Let's take a look at the first table. So we have the possible values of x, okay, so 0, 1, 2, 3, 4, 5, okay, no problem. We have the probabilities. If we check, they all are between 0 and 1, okay, so that's not a problem. What should I get when I add up these probabilities? Let's take a look at what these add up to right now. So 0.16 plus 0.18 plus 0.22 plus 0.10 plus 0.3 plus 0.01. And I get 0.97. There's something wrong here. If this is all the possible values of x, then this should be all the possible probabilities. So when I add them up, it should be everything. Okay? What's everything? Everything is 100%, which is the same thing as 1, right? So as a decimal, 100% is 1. When I add up all the probabilities, they should add up to 1. Okay, so this one's no good because the probabilities should add up to 1. So the first one's no good. What about this last one? If I check my probabilities, they are between 0 and 1. Okay, so that's it meets this requirement. Question is, do they add up to 1? Let's check. 0.06 plus 0.58 plus 0.22 plus 0.10 plus 0.03 plus 0.01. It is 1. So this last table is the only one that is a valid probability distribution. Okay, so in general, anything in this unit, if you get an answer for a probability that's not between 0 and 1, I can tell you right now that your answer is wrong. Okay, so if you get a number that's not between 0 and 1, check your work. Something went wrong somewhere. All right, so let's talk about some English. I have some English phrases here, and what I want to do here is make sure that we all agree what these English statements mean. Okay, so I'm going to translate these English statements to math symbols. And I'm going to start with this last one. X is exactly 11. How would you translate this to be a math symbol? What symbol would you put in the middle for x to be exactly 11? X is exactly 11. X is equal to 11. Let me go to x is more than 5. Or x is greater than 5. What symbol would you put in the middle here for greater than? Well, you put the greater than symbol. X is fewer than 15. X is less than 15. What symbol would you put in the middle? The less than sign. Okay, so I think those we don't have any disagreements on. So let's talk about the ones that I think we do need to talk about. The first one here. X is at least 21. So let's think about this. What do I mean by at least 21? If I say you have to be at least 21 to buy alcohol, what does that mean? It means you have to be 21 or older. So 21 or older, how would you write that? X is bigger than or equal to 21. Greater than or equal to 21. X is no more than 2. Or X is at most 2. What does that mean? If I say you can take at most 2 pieces of candy from my jar, what does that mean? It means the maximum you can take is 2. So you can take 2 or less. So 2 or less, you would write as less than or equal to 2. So use this table. So these phrases will appear again and again in this chapter. So use this table as a dictionary. Example 2. In the following probability distribution, the random variable x is the number of M&Ms in a fun-sized bag that are green. I have a table here. I have a missing number, so I do need to find this missing number first. These are supposed to be probabilities, so what do I know about probabilities? Well, I know that they should be between 0 and 1, but what else? I also know that they should add up to what? They should add up to 1. So I need to find this missing number to make sure that this adds up to 1. The easiest way to do this is just to add up the numbers that you have so far, the probabilities that you have so far. So 0.08 plus 0.11 plus 0.38 plus 0.14. So what I have so far is 0.71, and then subtract that from 1. So 1 minus 0.71, and I got 0.29. So this missing number is 0.29. Okay, you can double check, add them up, make sure it equals 1. Now write in symbols and find a probability. Okay, part A, what's the probability that a randomly selected fun-sized bag has exactly 5 green M&Ms? So in symbols, I'm looking for a probability that X is exactly 5. Exactly 5 means equal 5. Okay, so what's the probability that X is 5? Here's 5. The probability is 0.11. Part B, what's the probability that a randomly selected fun-sized bag has more than 6? In symbols, I want X more than 6 means greater than 6. And which X's are greater than 6? So the X's that are greater than 6 would be the 7 and the 8. So we're going to add up the probabilities for 7 and 8. So 0.29 plus 0.14. So 0.29 plus 0.14, 0.43. Part C, what's the probability that a randomly selected fun-sized bag has no more than 5? No more than 5. If you need to, go back to the definitions dictionary on the front page. No more than 5 is a less than or equal. So I should put less than or equal 5. Which numbers are less than or equal to 5? Less than or equal to 5 would be 5 or less, which is the 5 and the 4. We're going to do 0.11 plus 0.08. Okay, that's going to be 0.19. Part D, what's the probability that a randomly selected fun-sized bag has at least 5? Okay, let me go back to my dictionary on the front page. At least is it greater than or equal? So this is greater than or equal 5. All right, which X's are greater than or equal to 5? Greater than or equal to 5 would be 5, 6, 7, 8. So I'm going to add up the probabilities for 5, 6, 7, 8. So that's 0.11 plus 0.38 plus 0.29 plus 0.14. (0.92). Part E. What's the probability that a randomly selected fun-sized bag has at most 6? At most is a less than or equal. So this is less than or equal to 6. Less than or equal to 6 would mean 6 or less. So that's 6, 5, and 4. 0.38 plus 0.11 plus 0.08. 0.38 plus 0.11 plus 0.08. And that totals to 0.57. part F, what's the probability that a randomly selected fun size bag has less than 7? This one I think is pretty easy. I don't need the dictionary for this. This is going to be X is less than 7. Which X's are less than 7? Less than 7 would mean 6, 5, and 4. Adding those probabilities would be 0.38, 0.11, 0.08. So 0.38, 0.11, and then 0.08, which just happens to be the same numbers as in part E. So I know that this total is going to be 0.57. So that's just coincidence. The point of forcing things to be numbers is so that I can talk about things like the mean and the standard deviation. So let me start off by giving you the formulas for the mean and the standard deviation, and then we'll talk about how these formulas work. The mean. That's the symbol for mean, and then the formula is standard deviation. That's the symbol for standard deviation, and then the formula is okay. So I'm going to show you how these formulas work by hand. But you're not going to do it this way on the lab. So on the lab, we're going to be using Google Sheets and Excel. So let me make a note here. Okay, so don't do it this way on the lab. I'm only doing it by hand to show you how these formulas work. And maybe it's good for you to know how to do it by hand so that if Google Sheets doesn't work or gives you the wrong answer, you have a way to do it by hand to figure out what's going wrong. Okay, so we're going to find the mean and standard deviation for the table on the previous page, which is the one for the green M&Ms. So all I did here was I recopied that table right here, including the missing number. So let's start off by finding the mean. This formula is telling me to take the x and times it by the probability of x. So we're going to take the x times the probability of x. And we're going to do this for each x. Okay? And I'm going to organize this by making a new column, and I'll call it x times p of x. And I'm just going to take the x, which is the 4, times the probability of the 4, which is 0.08. So 4 times 0.08, 0.32. 5 times 0.11, 0.55. And then I'll tell you the other ones. The other ones are 2.28, 2.03, 1.12. Okay, so what we did was we did this part, right? X times p of x. And then what does this symbol mean? This symbol means add up that column. So we're going to add up that column. Okay, so 0.32 plus 0.55 plus 2.28 plus 2.03 plus 1.12. And I got 6.3. And that's the mean. So the mean is 6.3. Okay, next up is the standard deviation. So this is a longer formula. We're going to start with this part. So x minus that's the symbol for mean. So x minus the mean squared times p of x. And I'm going to organize this by making a new column that is x minus the mean squared times p of x. Okay, this is telling me to take each x, so that's a 4, minus, that's the symbol for mean. Our mean here was 6.3. So 4 minus 6.3, square it, and then times it by the probability of the x. probability of the 4, which is 0.08. And I'll calculate that later. Okay, do it for each x. So for next x, it's going to be 5 minus the mean, which should be the same, square it times the probability of the 5, which is 0.11. Next, 6 minus the mean, which is still 6.3, square it times the probability of the 6, 0.38. Next up is the 7 minus 6.3 squared times the probability of the 7, which is 0.29. And then 8 minus the mean squared times the probability of the 8, 0.14. And then I'll tell you what these answers should be. If you do this on your calculator and round it to 3 decimal places, you'll get 0.423, 0.186, 0.034, 0.142, and 0.405. So all we did was this part. Next up is this symbol, which means add up that column. I'm going to add up this column. So 0.4, 0.423 plus 0.186 plus 0.034 plus 0.142 plus 0.405, 1.19. Okay, one last step, which is this symbol. That means take the square root. So we're going to take the square root of 1.19. And then that should give us our standard deviation. So square root of 1.19 1.091. Okay, and that's our standard deviation. Okay, so before we move on, let me at least tell you where this formula comes from. Okay, so back in Unit 1, when we talked about means, we talked about finding the mean from a table. Okay, so here's a table that shows the frequency of our data, right? We talked about how to find a mean from a table like this. And we said we had to go back to the original data, right? So the table is telling me that there's 15 zeros, there are 21 ones, 17 twos, and 11 threes, right? We listed out 15 zeros, 21 ones, 17 twos, 11 threes. And then we added that up, and we said that instead of adding 0 plus 0 plus 0 plus 0 15 times, that's the same thing as doing 0 times 15. So really what we're doing is we're doing 0 times the frequency, 1 times the frequency, 2 times the frequency, and then 3 times the frequency, and added that up. Okay? Now, that's almost exactly what we're doing here. So here, I don't have a frequency table. I have a probability table. But what is probability? Right? These probabilities are, you can think of them as percentages, right? Which you should be thinking relative frequency, right? We also said that relative frequency was percentages. So this column here is really just the relative frequency. Okay, so instead of finding the mean from a frequency table, we're finding the mean from a relative frequency table. And we're really doing the same thing, right? We're taking the x times the relative frequency to get that, x times the relative frequency, x times the relative frequency, and then we added it up, okay, which is exactly what we did back in Unit 1, Section 3.1, right? X times the frequency, and then we added it up. And then in 3.1, we divided by the total number of data values, which we get by adding up all the frequencies. Now, here, We could have also added up the relative frequencies and then divided by that. But what do you get when you add up these numbers? What do you get when you add up these probabilities? You get 1, right? And so if you take anything and you divide by 1, you just get the same thing back, right? So we didn't have to divide by adding up the relative frequencies, because if you add up the relative frequencies, you're always going to get 1, and there's no point in dividing by 1, because you'll just get the same thing. So what we're doing here is exactly what we did back in section 3.1 when we talked about the mean for a frequency table. Okay, part B. If a fun-sized bag is selected at random, how many green M&Ms would you expect to find? Okay, keyword here is the word expect. Okay, anytime you hear the word expect in this unit, it's asking for the expected value. Which is really just another name for the mean. So this is really just looking for the mean, which we know is 6.3. Once you have the mean and standard deviation, we can talk about things like the empirical rule. Okay, which says put the mean in the middle. So our mean was 6.3. And then use the standard deviation to go up 3 times. Okay, so 6.3 plus our standard deviation, which was 1.091. Okay, that's 7.391. Okay, plus the standard deviation again, so 7.391 plus 1.091, 8.482. And then plus the standard deviation one more time, 8.482 plus 1.091, 9.573. And then go the other way, subtract 6.3 minus the standard deviation, which is 1.091, 5.209. Subtract it 2 more times, so 5.209 minus 1.091, 4.118, and then subtract it 1 more time, so 4.118 minus 1.091, 3.027. An empirical rule says from the mean, between 1 up, 1 down is 68% of your data. Between 2 up, 2 down is 95% of your data. And then between 3 up, 3 down is 99.7% of your data. Okay. It also gives us a criteria for what's considered usual and unusual. So typically, the 95% range, which is 2 up, 2 down, is considered usual. And then anything outside of that is considered unusual. So if you are in this range or this range, it's considered unusual. Okay, so the 95% range is the usual, so there's 95% of the time it's usual. And then what's on the outside then? If this is 95%, then the rest of it, which is 5%, is unusual. Part A. What would be considered usual and unusual for the number of green M&Ms in a fun-sized bag? Well, it's this picture, right? This range is usual, and then that range is unusual. So I'm going to say see picture above. Part B, what would be unusual? Would it be unusual if a randomly selected fun-sized bag had only 4 green M&Ms? So the question here is, where's 4? Is 4 in the usual zone or is 4 in the unusual zone? Where's 4? Where's 4 on this number line? Well, 4 is going to be to the left of that 4.118, right? If it's to the left of that 4.118, then that would put it in this unusual zone. So having only 4 green M&Ms would be considered unusual. Example 6. So this is the same green M&M table that we've talked about already. So I want to redo this problem using Google Sheets or Microsoft Excel. So it doesn't matter which one you use. It's going to be the same process. Before we switch over to Google Sheets though, this missing number, which we talked about already in example 2, was 0.29. So remember, it's basically find a missing number so that the probabilities add up to 1. Okay, now switching over to Google Sheets. Here we are. This is the single sign-on that you use to get onto Canvas. But instead of going into Canvas, I'm going to go into Google Drive. Once you're in, go to New, and you're going to create a new Google Sheets. And you can title it whatever you want to title it. I'm going to call this one Section 6.1. And what I want to do here is I want to copy this table. I want to type in this table. I have an X column. I have a P of X column. For my X column, it's 4, 5, 6, 7, 8. For my P of X column, I have 0.08, 0.11, 0.38, 0.29, 0.14. Okay, so what I want to do now is the only parts that you need Google Sheets for is to find the mean and the standard deviation. Because doing it by hand is a pain, right? Making this table by hand is a pain. So you're going to use Google Sheets to help you make this table. So I'm going to need these 2 extra columns. So I need an X times P of X, and then I need this column, X minus the mean squared times P of X. So I'm going to go and type those in. So I'm going to need a X P of X column. Okay, so X times P of X. The times is going to be the star, which is the symbol right above your 8. P of X. And then the 4th column is going to be parentheses, X minus the mean. There's no mu symbol, so I'm going to use M here for mean. Close parentheses, square it. So to square something, it's going to be the caret, up caret, which is the symbol above your 6, and then a 2. So that means square. And then times star, again, P of X. So we're going to have Google Sheets help us fill in this table. All you need to do is tell Google Sheets what to do on the first box, and then Google Sheets will do the rest for you, okay? So for this first box, I wanted to do X times P of X. So I wanted to do 4 times 0.08. So to tell Google Sheets to do something, you're always going to hit equals first. So equals, and then instead of typing stuff in, you're going to click. So I'm going to click on the X, which is the 4. Okay, notice that it fills it in with the address, the location of the 4, which is A2, right, the column and the row. And then times, which is a star again. And I want to times it by the P of X, which is that 0.08. So instead of typing that in, you're going to click on it. And it should fill it in with the address or location of the 0.08, which is B2. Okay, hit enter. Okay, there's an autofill. Most of the time it's correct, but for now I'm going to click no here. Okay. Now, that first box is now correct, and I need to just copy and paste that box to the rest of that column. So there's 2 ways to do this. You can move your cursor to the bottom right where that blue square is until you see a plus sign, and then click and drag it. And that will fill in the rest of the column. Another thing you can do is, I'm going to delete this, because what you're really doing there is just copy and pasting. You can just click on the first box here and just copy and paste it the long way, which is to go up to edit, copy, and then highlight the rest of that column, edit, paste. Okay. You can also do Command C or Control C to copy, Command V, Control V to paste also. Okay, so we have that column, and then to get the mean, we want to add up that column. So Google Sheets, to get it to add up the column, right? Anytime you want to tell Google Sheets to do something, you always start with the equals. So I'm going to put it right in this box here. Equals. To add stuff up, it's sum, S-U-M, parentheses, and then I'm going to highlight whatever I want Google Sheets to add up. And I want Google Sheets to add up that column. So I'm going to highlight that entire column. And just hit enter. 6.3. So that's the mean. So I'm going to label, just type in mean here, just to remind myself that that's the mean. Okay, that's the mean. And then to get my standard deviation, I need this fourth column. Okay, so set up that first box, and then Google Sheets will do the rest for you. So to tell Google Sheets to do something, hit equals. Okay, and now my formula starts off with a parentheses, X. So click on the X for that row, which is the 4. Okay, minus M, which is the mean. So click on the mean, which is a 6.3. Close parentheses, square it. So that's the up caret or up arrow looking thing, which is above your 6 and 2, so that squares it. Times is the star. P of X, so be careful that you click on the right thing. P of X is the 0.08, not the 0.32, right? 0.32 is the X P of X. Regular P of X is 0.08, so click on there. Don't click enter yet, because you need to put dollar signs on the address of the mean. So my mean here is the 6.3. There's like this purple box, and then there's this C8 on mine. It might be different on yours because you might have started in a different spot on your sheets. But you need to put dollar signs in front of the C and in front of the 8. So in front of the letter and in front of the number of whatever goes with your mean. Okay, and the reason why you need to do that is because when you do this copy and paste or this click and drag, what Google Sheets is doing is it's moving down the row. So for the next box, it's going to move the 4 down to the 5, and it's going to move the 0.08 down to the 0.11, which is what I want Google Sheets to do. Now, for the 6.3, it's also going to want to move down to the next box. But I don't want Google Sheets to do that because there's nothing in the next box. So I want Google Sheets to stay on that 6.3 for that entire column. And what the dollar sign does is it's telling Google Sheets to don't move this address, right? So stay on this 6.3. Don't move down as you fill in the row. Okay, so you need to put dollar signs in front of the letter and the number that goes with your mean. Okay, and then you can hit enter now. Okay, there's an autofill. This is most of the time correct. So if you want, you can just click on the check mark and it'll fill in the rest. But I'm going to do it the long way. So I'm going to go click on the first box again, and then click on a blue square, or move my cursor over the blue square until I see a plus sign, and then click and drag. Okay, that's one way. Or you can also copy and paste. So click on the first box, copy and paste it. So edit, copy, and highlight, edit, paste. Okay, so we got our column done for us, and then we just have 2 more steps. Add up the column, and then take a square root. Okay, so 2 very simple things to do. To add up the column, equals. Remember, to add up a column, it's SUM, sum. So equals SUM parentheses. Highlight what you want Google Sheets to add up. So I want Google Sheets to add up that very last column. Hit enter. 1.19. And then I want to take the square root of that. Right, so below that or anywhere you want, equals square root is SQRT, parentheses, and then click on whatever you want to take the square root of. So I want to click on the 1.19, then hit enter. And that's your standard deviation. So let me label that here, STDEV. Okay, and that's really all you need Google Sheets for. Okay, everything else you can do by hand. So I need the mean, which is 6.3, and I need the standard deviation, which is 1.091. Okay, so let's go back to the problem. Okay, so the two parts that I need Google Sheets for was actually part D. So part D says, if a fun size bag is selected at random, how many green M&Ms would you expect? So keyword is expect. It's asking for the expected value, which is the same thing as the mean. Okay, which we said the mean from Google Sheets was 6.3. Okay, so that's one part that you need Google Sheets for. The other part is part E here, where it says, would it be unusual if a randomly selected fun size bag had only 4 green M&Ms? Okay, so anytime you're asking about whether something is unusual or not, you need to make that empirical rule picture. So you need the mean, which it was 6.3, and you need the standard deviation, which was, what was it? It's right here, 1.091. Right, so for my empirical rule picture, I'm going to put the mean in the middle. And the range, or the range for usual versus unusual is the 2 up, 2 down number, right? So I need to go 2 up and then 2 down. I don't need the other numbers. I don't need the 1 up, 1 down, and I don't need the 3 up, 3 down. I just need the 2 up and the 2 down. So the quickest way to get to the 2 up and 2 down without having to find the 1 up first is to just go 6.3 plus 2 times the standard deviation, 1.091. Okay, so it's just this part is just adding the standard deviation 2 times. And then to get the 2 down number, you're going to do 6.3, which is the mean, minus 2 times the standard deviation. Okay, these calculations you can do by hand, no problem. But let me show you how you could do it in Google Sheets if you want. Okay, so here we're in Google Sheets. And I want to get the upper number and the lower number and the upper number for the criteria for usual and unusual. So lower, upper. Okay. So to get the lower, the mean minus 2 times the standard deviation. So I'm going to set that up in Google Sheets. So what I could do is, right, so to tell Google Sheets to do something, you also have to hit equal. So equals the mean, click on the mean, which is a 6.3, minus 2 times, so 2 star standard deviation, click on the standard deviation, and then hit enter. Okay, that's your lower number. I'm going to click no on this suggested. And to get the upper number, mean plus 2 times the standard deviation. Okay, equals mean, click on the mean, plus 2 times, so 2 star standard deviation, click on the standard deviation, and that's your upper number. So my lower number was 4.118. And my upper number was 8.482. Okay, so like I said, these calculations you can do on a regular calculator. You don't need Google Sheets for that. You only need Google Sheets to get this number and this number. Okay, everything else you can just do with a regular calculator. Okay, so now let's answer our questions. So is it unusual? So 2 up, 2 down. This is the usual zone. And everything else is unusual. So if you're in this area, whoops, sorry, or this area, these are unusual. So where's 4? 4 would be to the left of this 4.118, which would put it in the unusual zone. So this would be unusual. right, so let's go back and answer parts A, B, and C. Part A, what's the probability that a randomly selected fun size bag has more than 6? So what I'm looking for here is more than 6. More than 6 is greater than 6. That refers to 7 and 8. So you're going to add probabilities for 7 and 8. You could do this by hand, no problem. Let me show you, if you want to, how you could have Google Sheets add this for you. So I'm going to put parts A, B, and C right here. So A, B, C. Okay, so part A, I want to add up the probabilities for greater than 6, which means I want the 0.29 and the 0.14. So what you could do is, to tell Google Sheets to do something, just hit equals. And then to add stuff up, it's sum, parentheses, and then highlight what you want to add up. So I want to add up this 0.29 and this 0.14. Okay, 0.43 is the answer. Part B, what's the probability that a randomly selected fun size bag has at least 5? At least 5, if you need to, go to the dictionary on the front page. At least is greater than or equal to. Okay, so that means 5 or more. You can add this up by hand, no problem, it's not that bad. But let me show you in Google Sheets. So part B is this box here. Equals, SUM, parentheses, and then highlight what you want to add up. So greater than or equal to 5 means 5 or more. So I want this 0.11 all the way down to this 0.14. And then hit enter. 0.92. And part C, what's the probability that a randomly selected fun size bag has at most 6? At most, less than or equal. Okay, you could add this by hand, not a problem, but in Google Sheets, so I want part C to be in this box, equals, SUM, parentheses, less than or equal to 6 means 6 or less, so I want this 0.38, 0.11, and this 0.08, and then hit enter. 0.57. Example 7. The following table shows the number of classes that students are taking during the fall 2019 semester. What's the difference between the table in example 7 here compared to the table in example 6 that we just did? In example 6, I'm giving you the x's and I'm giving you the p of x, the probabilities. In example 7, I'm giving you number of classes. These are actually your x's. But am I giving you the probabilities in example 7? No, I'm giving you the frequency. These are nice whole numbers, right? These aren't the decimal probabilities that we had in example 6. So for example 7, we have to go one extra step and get the probabilities first. And the probabilities are really just the same thing as the relative frequencies. Okay, so we're not going to do this by hand. We're going to do this in Google Sheets. So I'm going to switch over to Google Sheets. And then I'm going to type in that table. So I'm going to, doesn't matter where you start here. I'm going to scroll down. Okay. So my x's, and then I have my frequencies. Okay, so the x's are a number of classes, and they were 1, 2, 3, 4, 5. My frequencies are 5, 17, 25, 36, and 2. Okay, so the goal here is I need to first get a P of X column. Okay, and then I need to get those two other columns just like in example 6. So I need a x times p of x column, and then I need a parentheses x minus the mean, so x minus m, parentheses squared, so that's the up caret or hat symbol above your 6 over 2, times star p of x. Okay, so how do I find the p of x column? So the p of x column is really just the probabilities, or the same thing as relative frequency, which we know how to do from Unit 1. To get the relative frequencies, we're going to divide each of these regular frequencies by the total. Okay, so I'm going to first find the total. I'm going to put the total right here. I usually put a space so that I'm not confused that this total doesn't really go with these frequency numbers. So I leave a space, and I'm going to put the total right here. So remember, to tell Google Sheets to do something, you're going to hit equals, and then to add stuff up, it's sum, and I want to add up that frequency column to get my total. Okay, total is 85. Now, I want to do 5 divided by 85, 17 divided by 85, and so on. So all I need to do is get Google Sheets to do it in this first box, and then Google Sheets will do the rest for me. So first box, to tell Google Sheets to do something, start off with equals, and I want it to do 5 divided by 85. Okay, I'm not going to type it in. I'm going to click. I'm going to click on the 5, divide, and now I'm going to click on the 85. Now, the first tricky part here is I need to put dollar signs on that 85, which for mine is on this. Mine is on this B33. So I'm going to put dollar signs. Your actual letter and number might be different, but whatever color goes with that 85, put dollar signs in front of the letter and the number. And the reason here is when Google Sheets goes and fills in the rest of the column, right? I want the 5 to move down to 17, but I don't want the 85 to move down to this blank spot here, right? I want the 85 to stay there. So the dollar sign tells Google Sheets to stay on that 85, and hit enter. And then you're going to click and drag. So click on this, the first one, move your cursor to the bottom right square, blue square, until you see a plus sign, and then drag it. Or you can just copy and paste it down there. Okay. So I have my P of X column. You can now forget about this frequency column because we're not going to use it for the rest of this problem. To get the X P of X column, first box, equals. And now I want to do X times P of X. So you have to be careful here. Which number is your X? It's the 1. Okay. Times star P of X. Which number is your P of X? It's the 0.0588. So click on that. Hit enter. And then click and drag that. Okay, so I'm going to click on that first box. Bottom right box, blue box, or blue square, until I see a plus sign, click and drag. Okay, that fills in my column. To get my mean, I want to add up that column. Okay, so I'm going to put it in this box here with the space in between. You don't have to, but that just tells me that this is separate from the actual table. So equals, to add up stuff, it's SUM, parentheses, and then highlight what you want to add up. I want to add up that entire column. And hit enter. 3.153, that's my mean. I'll put it down here. Okay, that's my mean. For my last column here, first box, equals, to tell Google Sheets to do something, it's parentheses, X. Okay, click on the X. Make sure you click the right thing. So our X in this row is actually the 1, minus M, which is the mean. Click on the mean. So this is this number, this 3.153 that we just found. Close parentheses, square it. So that's the up caret, the thing above the 6, 2, times the star P of X. There's lots of numbers here. Make sure you click on the right P of X. I want the regular P of X. So this one right here. not this one, right? This one is x p of x. I want the regular p of x, which is this one. And then remember, you need dollar signs in front on the mean. So my mean is this D33 here. I need dollar sign in front of the letter and in front of the number. And hit enter. And then you can click and drag this. And then 2 more steps. I want to add up that last column and then take a square root. So to add up that last column, I'm going to click here, equals, SUM parentheses, add up that last column. Okay, that's not my standard deviation yet. I need to take a square root. So below it, equals, SQRT, parentheses, and then click on what you want to take the square root of, which is this 0.929550. Okay, and that's my standard deviation. Okay, and that's really all you need Google Sheets for. Okay, so once again, the 2 places that are tricky is in finding the p of x, right? You need to put dollar signs in for dollar signs on the letter and number of the total. Okay, and also for the last column on the mean. Okay, so those are 2 places that you need dollar signs on questions like this where you're given the frequency. Okay, on questions like the example 6, where you're given the probabilities already and you don't have that frequency column, you need dollar signs on that last column on the mean. Okay, so we have everything I need. Let's go back and answer the questions. Okay, so let's go start at the bottom, the 2 places where I know I need the mean and the standard deviation. Okay, the part D. If a randomly selected student, if a student is randomly selected, how many classes would you expect the student to be taking? So that's, I'm asking for the mean here, which is the same thing as the expected value. The mean we said was this number, so 3.153. So round to 3 decimal places, 3.153. Okay. Part E, would it be unusual, right? What I'm asking for here is make that empirical rule picture, right, which gives you the usual zone and the unusual zone, which means I need the mean and the standard deviation here. The mean was 3.153. The standard deviation was this number, 0.964. Okay, put the mean in the middle, which is actually this one. I'm gonna do this one in Google Sheets. So in general, you can put the mean in the middle. Right, that's the symbol for mean, and then to go 2 up, 2 down. To jump directly to 2 up, you're gonna go mean plus 2 times the standard deviation. To go 2 down, you're gonna go mean minus 2 times standard deviation. Okay, so these 2 you can do on a regular calculator. The mean plus 2 times the standard deviation, and then the mean minus 2 times the standard deviation. But let me do it on Google Sheets just to show you. So I'll put it right here. I want the lower number and the upper number. Lower number, okay, start off with equals to tell Google Sheets to do something. Mean, click on the mean, minus 2 times, so 2 star, click on the standard deviation. Right, make sure you're clicking on the right standard deviation and not the number above it. Okay, that should be the low number. The upper number, equals, click on the mean, plus 2 times, so 2 star, click on the standard deviation, and that's the upper number. Okay, so let me write these down. The lower number is 1.225. And the upper number is 5.081. Okay, and then to answer the question, if you're in between, that's usual. If you're on the outside here, that's unusual. Okay, and the question is, where's 5? Is 5 in the unusual zone or is 5 in the usual zone? Here's 5.081. 5 will be to the left of that, which would put it in the usual zone. So, usual. Okay. I don't remember if on the lab I have it as usual or do I have it as not unusual. So usual is the same thing as saying not unusual. Actually, I think I have it as usual and unusual because not unusual sounds kind of funny. Okay. Anyway, now back to parts A, B, and C. Okay. If a student is random selected, what's the probability that they are taking 3 or more classes? So 3 or more classes. What is 3 or more classes? Well, 3 or more classes, that's greater than or equal to. Let me actually set these up right now, and then we'll just go to Google Sheets and do it. Part B, if a student is randomly selected, what's the probability that they are taking no more than 2? No more than 2, no more than 2, no more than is less than or equal. Okay, so this is less than or equal to 2. Part C, if a student is random selected, find a probability that they are taking less than 5. Less than 5 is pretty easy. Less than 5. Okay, so I want greater than or equal to 3, less than or equal to 2, and then less than 5. Okay, so you could just add things up by hand. And what I mean add up, you're going to add up the probabilities. So greater than or equal to 3. Okay, we don't care about the frequency column. I care about the probability column, which is this P of X. So greater than or equal to 3 would be 3, 4, and 5. So I want these. Okay? So you can add those up by hand, but I'm going to have Google Sheets add it up for me. So equals, to add things up, SUM, parentheses. Greater than or equal to 3 would be these numbers. Okay, make sure you're highlighting the P of X column and not the XP of X, right? Because I want the regular probabilities here. Okay, so that's the answer for part A. Equals, SUM parentheses. For part B, I want less than or equal to 2. Less than or equal to 2 would be just the probabilities for 2 and 1, which are these two. Okay, and then part C, less than 5. That's equals, SUM parentheses. Less than 5 would be the 4 all the way down to the 1. So 4, those. Equals. And then let's go back and write down the answers. So part A, 0.741. Part B, 0.259. And then part C, 0.976. All right, so my recommendation is to practice, try to follow what I just did, and make sure you're able to get the right answers on example 7 and example 6. Right? Your lab for this section is basically example 6 and example 7. So you have one where, well, you have two where I give you the probabilities, which should be like example 6, and then you have two where I don't give you the probabilities, I give you the frequency, which should be exactly like example 7. So make sure you follow the video and make sure you're able to do and get the answers that I got on example 6 and example 7 before going into the lab. All right, that's it for today. Have a good day, and I will see you in the next video.